All right, let's do a little iteration. Let's do a little iteration to compute compound interest. The idea is this. Okay, so you've got a bank account. Okay, you'll put money into this bank account, and this bank account pays a certain return rate, which we will assume is a percent. So, like, I don't know if it was 2%. What that means is that every year they will take 2% of what is in the account and add that to the account. So, for instance, if you had, I don't know, $1,000 in the account, I'll do a little console work here. If you had $1,000 in the account, then at the end of a year, what would be added to that would be 1,000 times 2%, which is, as you know, 0.02. And then that would be the amount that would be in your account after 1 year. And then what would be the amount in the account after 2 years? Well, you don't add in the interest on that initial 1,000. You add in the interest on the amount of the account at that 2 year period, which is 1020, as we saw before. So we would add into 1020 times, and let's say once again that the percent rate is 2, that is 0.02. So that's what we would have after 2 years, okay? And notice as well that this is not linear. I wanted to make a mathematical point here. So notice that we went from 1,000 to 1,020 initially. That's a gain of $20. And then we went from 1,020 to 1,040 and 40 cents. So the additional amount that was put in the account after 2 years was more than the additional amount that was put in after 1 year because there was more money in the account to begin from year one to year two. That's how interest compounds, right? So you not only get interest on what the initial amount was, but anything you would earn in successive years through interest. So let's write some code that will actually make this happen. So I've got a function called CI for compound interest. It has three input values. The first is the initial amount. That is what you put into the account. N is the number of years that it will be left in the account. And then R is the percent rate of return, like 2%, which of course we'll have to convert into a decimal. So let's see. So what we need to do is this, is we need to loop for sure because we have a process that we wish to undergo a number of times. And it is ultimately the same process, which is take the current amount in the account, add to that the amount times the rate, and then make that the new amount. Okay, so of course that's a variable update, but this is a process that we will carry out multiple times. And if ever we have a process that we wish to carry out multiple times, that's a loop, in this case a for loop, and we know precisely how many times we need to do it because that's the number of the years. So I'll talk about the loop variable in just a moment in range n. Okay, so the loop variable is simply the underscore, which is a perfectly fine variable. And the reason that I use the underscore is that even though Python requires that we have a loop variable between the keywords for and in, we will make no use of it. So we'll just simply use the underscore. But you can call it whatever you like. You could call it year, for instance, if you wanted, if that made sense to you. All right, as for range n, well, that'll be the range 0, 1, 2, and so on up to n minus 1. Now, it's not particularly important what the values are in that range. What's important to us here is that it happened in times, okay? So you could construct whatever range you wanted, so long as it would actually contain n members. So it could go 1 to n plus 1, it could go 2 to n plus 2, and so on, but the easiest way to do it is simply range n. Okay, so what do we need to do? Well, we need to take the value of I and we need to update it. Okay, so how will we update the value of I? Well, just like we did in the console, we will take the current value of I and we will add to that I times the rate. And the rate is given as a percent, so it has to be divided by 100 to give us the decimal form. And then we multiply that by I, and then we add that to I. That's the right side of the assignment statement here, and then we make that the new value of I. So this is a update. Okay, so we had an initial value, which was given to us when the function was called, and then we updated that initial value, and we will do that n times, and then we will finally return the value of n. It's really a very simple function, isn't it? Okay, return the value of I meant to say. Now, it's entirely possible that we could have created a new variable, excuse me, to hold the value in the account at a particular moment in time and let I simply hold that initial amount. But there's no reason to not just update it, okay? In the way that we did. We really only need, since we can update the value of a variable, we really only need one variable. So, efficiency suggests that we'll just use the variable I. Okay, so let's run this. And let's see. So I'm going to call compound interest. So let us say that we send it $1,000. We'll compound for 1 year and a percent rate of 2. Oh, and that's the number that we saw before. So now let's let it go 2 years. Ooh, that's also the number that we saw before. So I have confidence that our number is correct. So 10 years, after 10 years, you've made what, 200 and something dollars. So let's see, what have you made after 20 years? You've made about almost $500. So let's say 30 years. What have you made? About $800. Let me show you just sort of something curious about how this depends. I'll make it 30 years. How this depends on the rate of interest. Okay, so I made about $800 at 2%. Oh, wow, at 4%, I made about $1,200. 4% is a good rate of return. So what is it at 6%? Oh, wow. We're getting up near the $5,000 mark. So let's say that you could get 8%. Wow, I've just made $9,000. Let's say that one could get 10% over 30 years. Wow, I've made like almost $17,000. So notice that the better the rate of return, the of course more money that you will make, and it's not linear, right? The higher the percentage is, just even a 1% increase will give you much more than just um, the same increase that you got from say 8 to 9. The increase from 9 to 10 will be more. All right, so that's compound interest. The sort of financial advice to the side, that is, get the best rate of return that you can. That's what the code looks like. Okay, and this is the classic pattern of we enter into a for loop and we update the initial value of some variable, and then when the for loop is complete, we return the final value.